that are probably to your benefit today to understand. Okay? Two things. You don't necessarily need to write this part down right here. You don't really need to write this part down. If I threw an equation up here that was linear like this, every single one of you should be able to solve a linear equation like 2x plus 6 equals 42. So my steps for solving that would be minus 6 divided by 2, right? So I'll have 2x is 36 here. And you don't need to write this down. Just make sure you're with me on this. Okay, so what's your x value going to be there? 18, okay. Now, you've also talked an awful lot about this in the past, hopefully. What's the word I'm putting up here? Quadratics. Anything to what power or what degree, if you will? Second degree. Okay, anything second degree. So if I had said something, let's solve something like this. X squared plus 4x equals 0 like this. What could I factor out right there? I could factor an x out. So this would become x times x plus 4. Set that equal to 0. Now if I split this by 0 product right here, it means that the x could be what value? Or what value would you throw into the quantity x plus 4 to make that 0? Negative 4. So my solutions could be 0 or what here? Negative 4. Okay? We've seen that stuff before, right? Okay. Well, what happens if I start running into stuff like this? Let's talk about quadratics in the form of ax squared plus bx plus c equals 0. You guys fill me in on how you solve something like that. Say something like 5x squared.
Is this what Miss Hild has a song for?
Yeah, she does. I couldn't make it on American Idol, so I'm not going to sing today, all right? I guess I'm going to ask you guys from previous experience in your past math classes, how have you handled that? Quadratic formula. Anybody want to sing the song? X equals the opposite of B, plus or minus, like I said. All right, I'm not going to rap it because it's not going to go. Give me a show of hands if you've seen that before. Quadratic formula, right? Okay. All right. How many of you would like it if I would say you have to use quadratic formula for every problem that involves quadratic formula today? You have to write it all out. How many would like me if I did that?
We don't get to use the
How many of you would just like to say, hey, I would just like to punch my A, B, and C values in and get the roots right away? Okay. We've all done this before, right? Right? You've got to understand something right here, though. In order to make this work, what does this value on the end have to equal? Your quadratic function has to equal what value? 0. Does that make sense? Okay, so what would I have to do to both sides here to make this work? What would I have to do to both sides to make this work? What do I have over here as a constant on the right? 6. So wouldn't you have to subtract 6 from both sides to make this equal to 0 before I can even use the formula? So the only time the quadratic is going to work is when you have ax squared plus bx plus c equal to what value? 0. Okay. So in this case right here, this would get written as 5x squared plus 8x. What are you going to have for your c value here? If I subtract 6 here and I subtract 6 here, what are you going to have? Plus 14, right? So to make sure we understand this right here, do we understand why this is a quadratic? What's the highest degree? 2. Okay. What would your a value be in this situation? What's the a value in this situation?
5.
It's 5, right? What's your b value? And what's the c value? Okay. Do we understand that? The a, b, and c values off of any quadratic? Yes? No? Yes? Okay. Well, let's jump into this, all right? Guys, you have most of the notes written for you already, and I'm going to kind of rewrite these problems down here again and talk about what the heck is even going on. But in your 7.5 notes, we're talking about solving trig equations, all right? Our job now is the following. It's not to do an identity. It's not to punch stuff into a formula. Your job is to figure out a value of x. So in other words, your x value or your sometimes your theta value, we're going to be solving this as an exact value. You're going to end up with some number, okay? And I think the one that I'm going to choose to start with right here, and everything's kind of written down here for you, is this first example. And I'm going to write the workout again, okay? But before I rewrite this, I want to read this about solving trig equations. It says very much like we can solve any equation involving a variable, we can also solve a trig equation. Most often they will involve, what's the word here? Substitution, okay? Typically where you have a trig function like cosine of x, or say sine of x, or say tangent of x, you are going to replace that trig function with a variable. That's going to be what we call the substitution, okay? So in this situation right here, your example 1, read the problem to me. You don't need to write it down because it's already there for you, but just we'll kind of walk our way through this. In example 1, what's that problem say? Solve for what?
1 minus the cosine of 2x.
Let me see. I'm right here, this example right here.
Yeah, I read the wrong one, I'm sorry.
Okay, I want to do this example right here. Okay? So somebody read that again to me. It's 2 cosine squared of x minus
5 cosine x plus 2
equals
0.
Okay, here's the deal. When you're working with these, your first goal is to try and get your equation written so it's in terms of one trig function. In other words, just cosine, just sine, just tangent, whatever it is. As I look through this here, I've got some cosines here and some cosines here. Are those trig functions exactly the same? They are, right? Now, I don't like the way this looks, okay? But what I want you to understand this is the following. Our job is to try and solve for your x value, okay? Solve for x. All right, and here's where the substitution comes into play. First of all, are we in terms of one trig function here? You bet we are, actually. It's just cosines, right? It's just cosines, right? I don't have cosine and sine, do I? I have just some cosines in here, right? Okay. I said let's replace the trig function. So this is where your substitution comes into play. On the notes it says substitute, right? And by substituting, here's what I'm going to say. Did we use the letter V on the notes? Is that what we use?
Yep.
Okay, we're going to say in this substitution, let V equal that trig function. So what is that trig function I'm letting it equal? Cosine of what? Okay. So if I put a V in everywhere where I have a cosine of x right up here, let's rewrite this to see what it looks like. This becomes 2, and for this cosine of x, what are you going to put in? V and then square it, because this cosine is getting squared, right? Minus what?
5b
Plus? And set that equal to what value here?
0.
All right. Number 1, number 2. I know neither one of them are very nice, but which one looks more friendly of the two? 2 does, right? Isn't that a quadratic? Isn't that what we just got done talking about here? Okay. Now, I don't know what you guys have for quadratic formula calculators, but if you want to, this is what I would suggest. If you can get to my webpage, have you guys got my webpage? Yes? No? Didn't we do a calculator in there once? Well, if not, just Google up Mr. Parsons' math page. Just Google Mr. Parsons' math page. And it should come up to something that looks like, well, if the internet's going to decide to work, it should look like this right here. Okay? We've got our good school logo and something you'd probably like to put on a dartboard on that page, okay? Is there anybody that needs help getting there? You guys see the calculators link over here on the left? If you don't have a quadratic formula calculator, click calculators. And I think I've got one in here. I thought I did.
Yeah.
Is there a quadratic
Yeah,
formula
scroll
calculator?
down.
Yeah, let's go right here. Okay. Is there anybody that's way behind me right now? Just not sure? Let's see what this looks like. I'll roll down. what's going on. Are your guys' calculators slow? I'm sorry, your Chromebook's slow? No? Okay. Alright, kiddos, here's what we're going to do. Do you guys see where I'm at right here? Enter your A, B, and C values. So what am I going to put in here for my A value? According to this equation where I'm at, I have 2b squared minus 5b plus 2. What's the A value going to be? What's the B value going to be? What kind of 5 is that?
Negative.
-5. Plug that in. And what's the C value going to be? Okay, plug those in. And what this is allowing us to do is to find the roots. This is allowing us to solve for V. So I'll punch them in up here quickly as you are. And let's see if we get the same values here. Hopefully we do. So in my calculator, I'm going, what do we say, 2, -5, and 2?
Shows you all the work.
Carson, is this a clipboard that has a calculator connected?
Yeah. Isn't that cool? What do I get for my solutions here, gang?
2 and
What's that?
I don't know when you'll need it, but it's neat.
I like it for track season. When I'm trying to figure out splits. Make sense?
Kind of, but,
But as a math teacher, I should just be able to do it in my head, right?
well, I don't know, aren't the splits on the timer?
Yeah, but sometimes I mess up the timer, so I've got to go back and I get too excited with what the kids are doing and I forget to take a split. Okay. What are my solutions here, kiddos? 2 and 5, right? Or 2 and 0.5, I meant. I'm sorry, 2 and 0.5, right? Okay, now, back in your notes right here, here's where things get pretty interesting. And it's already written for you in this first page, but this implies that after I plug this stuff in right here, guys, this says that V can equal 2 or V can equal 1/2. Now, once you get to this part right here, this is a part, once you solve for your V value, you want to back substitute. I think in the notes they refer to it as unsubstitute, is that right? Okay, back substitute is what I like to do. I said, what do we let V equal in the first place, gang? So from this I can imply right here, I can imply that, well, you know what? V was the same as cosine of x, so this is saying the cosine of x can equal 2, or the cosine of x can be what? Well, it can equal 1/2, right? 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 Okay. Well, look at your chart right here, guys. Go down to the cosine column. This cosine column for your special angles. Does the cosine of that angle ever equal 2 anywhere? No. And another thing I could do, guys, is this. I could invert this. I could say the cosine inverse of 2 would give me an angle, wouldn't it? Okay, or I could do the cosine inverse of 1/2. Well, here's the situation. Draw a unit circle over here on the side. Guys, a unit circle is a circle based with a certain radius, and that radius is 1 unit. Okay? So what's the highest value out here you'll ever get? +1, right? What's the furthest to the left you'll ever get? -1. So won't your cosine value always be between -1 and +1? So I think back here in the notes, it says, well, we've gotten to here where cosine of x can be 1/2 or it can be 2. What's this say right here? It's ridiculous. And why are you throwing it out? Doesn't fit. Not even on the unit circle. Okay? So it says the cosine of x can equal what value here, guys? 1/2, right? Now, what I'm going to say is this. I want you to start using your chart for this. Now, I want you to look for answers that fit the window from 0 less than or equal to x less than 360 degrees. We want to talk about our angles as they would relate to 1 full revolution on unit circle. Okay? So go through your chart and go down the cosine column. And does 1/2 ever appear in that column? How many times? Twice. What are your angles? I agree with x is equal to 60 degrees. However, I could also say x equals what? 300, right? Guys, go down to 300 degrees right here. I went to my cosine column. Don't you have another positive 1/2 right here at how many degrees? 300. So what's another solution to this? 300. Isn't that another one that's going to fit that window? So what are your x values in this? 60 and 300. Okay. Now it says always do what?
Check.
Always check your answers. Okay? Always check your answers. Well, you really no need to do that here. We've kind of worked it. We can do this if we want to. Somebody punch up the cosine of 60 degrees for me. Actually, I'll do it. I'll do the punching up. I like to punch stuff up. What's one answer I'm going to throw back into this game? So it'll be cosine of 60 degrees. Okay, so I'm going to go 60 degrees. I'm going to hit the cosine. You guys got it? What is the cosine of 60 degrees? 1/2, right? So every time I have cosine of 60 degrees, that's really going to be 1/2, isn't it? So if I substitute it back in, wouldn't this really be 2 times 1/2 squared? That would be the cosine of 60 right here. Half squared, right? Minus 5 times the cosine of 60. Well, cosine of 60 again was what fraction? 1/2. Yep, 1/2. 5 times 1/2. Plus 2. This had better equal what value, gang? Better equal 0. Okay, check it out. What's half squared?
1/4.
1/4. 2 times a fourth is a. So this is really equal to 1/2. What's 5 times 1/2, or half of 5?
2/5.
Minus 2.5 plus 2. Oh my gosh. Half minus 2.5 is -2, isn't it? -2 plus 2 more is what? 0. Does it hold? Okay. Your job basically is to substitute, figure out what your values are that you're going to be equal to within a distance from -1 to +1. Once you figured out what that fraction is, find your angle that corresponds to it. You've got it. So let's try another one here. Down below there's a general guideline. It says if an equation has more than one trig function in it, you should try to change it into what? One or the other. Okay, now, again, I'm going to tell you this. Don't lose sight of some of the addition and subtraction identities that we had, or sum and difference identities. Don't lose sight of the double angle identities and the half angle identities. You might still need to refer to those previous sections. In this example right here, we are all of a sudden saying 1 minus cosine of, oh, this is interesting. 1 minus cosine of, what did I put parentheses around? 2x. What kind of angle is that? Double angle from last section. Okay. Minus sine of x is what value? 0. Well, let's see how they handle that on the next page here. Let's try this. Let's see how this gets handled. What do you think we're going to change first of all?
The double.
We're going to change that double angle. Okay. It says this equation has both a sine and a cosine in it. It would sure be great if it only had sine or cosine in it. So we're going to change either the sine into a cosine or a cosine into a sine. And we've already identified right here. We see cosine of what here, gang? We see cosine of 2x, and that changes into the sine easily. Here's one of your double angle identities right here. It says the cosine of 2x is equal to what here? What's it say? 1 minus 2 sine squared of x. So, in this original problem, which is right here, in the original problem, the cosine of 2x is going to get replaced with what? You guys agree? How does that benefit us? We've gone from cosine and sine down to one function, just the sine, right? You guys agree? Okay? You guys look like you're at the end of a day of a long week.
And it wasn't even a full week.
Wasn't even a full week. Well, here's what we end up with, guys. We have 1 minus this mess up here. When I distribute the negative to everything in here, we get 1 minus 1. This negative makes that negative a positive. So right here, what do the ones do to each other, actually? cancel. So now I've got 2 sine squared minus sine of x. Now again, right here, once I get stuff written down, it's always good to have these equal what value on the end? 0. Okay, so once I've got it down to one function and it's equal to 0 in simplified form, we're going to substitute. So what are we going to let v equal this time, guys? Sine of x. So I'm telling you, after you've got that in there, use your quadratic formula. By the way, what would your a value be in this equation at this line? What's your a value in that? 2. How about your b value? Careful.
Negative 1.
-1, right? Isn't this minus 1v? How about the c value? I don't see a c value. Got to be 0. Okay, so when we plug stuff in, you have v can equal 0 or v is 1/2. And let's just confirm that. Somebody go to your calculator here. Plug in on your a, b, and c values up here again. Plug in, what was it, 2, -1, and 0? Let's see if I can do that quickly here. I'm sorry, what did you say, Kaylee? 0.5 and 0. Okay, so you get 0.5 and 0. I just want to plug this in and make sure that I know how to do this if I have to down the road. Text tools. Let me see. By the way, Kaylee, Jackie, what time are you guys leaving tonight?
425.
4:25? Okay. What did we say they were? 2, -1, and what was the other one? 0? Okay, so we'll go ahead and solve this. Getting 0.5 and 0. The nice thing I like about this calculator, you don't even have to kid it. It's already solved it for you once you put your values in. Okay? So 0.5 and 0. So in the notes, does that match this value and this value? So once I figured out what v has to equal, they use the term unsubstitute. You might hear me say back substitute. What was v equivalent to? What did we substitute the v for originally? This means the sine of x can be, or the sine of x can be. Okay. That's good because if I go down the sine column, does 0 ever occur in the sine column?
Yes.
What angles? 0 degrees. I keep following down. Oh, it happens again at 180 and 360 if you wanted to put it in there. Now I'm saying if you put 0 in there, 0 is really equivalent to what all the time? 360. So if you put 0 in, don't worry about 360. So we'll say for our answer or our windows that we're looking at, you can use 0 but forget 360. Fair deal? All right. Well, 0, 180. Where did the 30 and 150 come from, kiddos? Comes from the 1/2. These are the angles within one revolution where the sine of those angles would equal to, or be equal to, 1/2. Okay? So what are your solutions for this equation?
0, 180, 30, 50.
Okay. Guys following this okay?
So how many solutions can you have?
Typically, the most you'll have is 4.
Do you know like how many you're gonna?
No. Never know. In fact, you're going to get mad at me when I start throwing double angles in there and start there's going to be times when there could be 8. Oh, that's the look, Jackie. I love it. Honestly, I think the most that you have on your assignment is 4. The one problems that I picked out, I think that the most you have is 4, and I'm actually going to probably go through and tell you how many to expect, okay? Make sense? And honestly, I think the ones I assigned you are odds, so you can check that, all right? Okay, let's look at the next example. Are you guys following this so far? Makes sense? Okay, what about an example like this? First of all, is this even a quadratic at all?
No.
It's not, okay? Now sometimes when you get an equation like this one right here, and you might put a star by this example, you're going to run into a situation where your equation involves a what? It says you must take into consideration where the denominator equals what? 0 as a solution, okay? Oh boy. All right. What are we trying to solve right here? Sine of x plus cosine of x is what value? 0. All right, well, let's see what they've got on the next page here for us. Oh, this is a different problem, isn't it? Did I miss a page here somewhere? If I did, no worries. Let's go back to that then. Let's work this. Right? Right here, this is a tough problem. Previous examples, I've always said, try to find or rewrite the equation so that you're involving just how many functions? 1. Okay. Well, this one here, sine of x, cosine of x. Is there any squaring going on at all? No. Boy, oh boy, oh boy. How about any double angle or half angle identities here? Oh boy. Okay. Something like this, you might have to just kind of think through logically. Okay. And here's how I would tell you to handle this right here. There's nothing we can really change here to get this down to one function. However, do you agree that I could do the following? Could I say the sine of some angle equals the opposite of the cosine of that angle? All I did to both sides was what? I subtracted cosine of x from both sides, didn't I? Right? Okay. Now, I don't know if you have your unit circle or if you have your unit circle chart, but the first question I'm going to ask you is this. The way I've got this set up, what sign is in front of the sine function here? Positive or negative? What's over here? So what's going to be true about the signs of the solutions? Wouldn't it be kind of opposite of each other? Okay, here's a question for you then. Since I have two functions to worry about here, in this case sine and cosine, I want you to jump into the sine and cosine column. Okay, jump into the sine and cosine column. Now what I want you to do is I want you to follow those two columns simultaneously all the way down, and I want you to pick out parts where it looks like you might have the same exact value, but in that situation, one's got to be positive, the other would have to be negative. So you might have a -6 over here and a +6 over here. See what angles that happens at. Okay, I'm hearing 315 a lot. Jump down to 315 degrees. Does it look like the sine and the cosine are opposites of each other? They are. So 315 would work. Is there another situation?
35.
135? 135? Okay. I have a question for you guys. What's the sine of 135 degrees? Root 2 over 2, right? What's cosine of 135 degrees? If I added those two together, like they suggested in the beginning of the problem, if I add those two together, what would they equal? 0. So what two angles am I looking for here?
135.
Okay, so x equal 135, 315 degrees. Okay, that's what you would have there. Okay, so again, this one's kind of tricky because were we able to get down to just one function here? Were we able to get down to just one function? Answer was no. Okay, so this is where we're going to say, okay, this has got to equal this. Find out where they are the same exact value. One's just opposite of the other. Okay? All right. This is going to apply to what's on the next page. It says, if your equation involves a fraction, you must take into consideration where the denominator equals 0 as a solution. Okay? Denominator equals 0 as a solution. So let's look at what they're talking about here. Try and get through this last page here quickly. Okay. An example. We've got a sine of what first? Got a double angle here minus a sine of x. Here it's suggesting that we change this double angle into its identity. And its identity is what here, gang? Well, the identity for sine of 2x is that mess right there. Okay? Now, I'd probably have done this a little bit differently than it's written up here, but the way they're going to do it is okay. The way they're going to do it is okay. Oh, I don't like this. Can I do this differently? Can I write a different version on the other side? Okay. Here's my suggestion. I would factor out a sine function, okay? In this right here, you have 2 sine of x cosine of x minus what? Sine of x. The way I would have probably gone about it is this. This is how I want to write this. I don't like the way that this is written. I'm going to change this to the following. I call this 2 sine of x cosine of x minus the sine of x, still equal to what value, kiddos? 0, okay? Do you agree that I could factor a sine of x out of each part on the left side? You guys agree with that? So if I pull sine of x out of this first part, let's write it like this. This will be sine of x times, okay, here we go. If I pull it out of here, or divide that out of here, what's left? 2 cosine of x, right? And just checking back by distribution, if I would multiply by sine x, we'd have this first part right here, right? What am I going to have after the minus sign in parentheses now to make this a sine of x? Sine of x times what right here would make that 1, right? Okay, you agree with that? You guys agree with that? Okay, so by 0 property, my first part or my second part could be equal to what value? Could be equal to 0. Okay, it's just like saying this. If you have an a times a b, a first part times a second part, like I do down here, sine of x is the first, parentheses is the second set. If this ever equals 0, this means that either a equals 0 or what else? Or b equals 0. So I'm going to make a t-chart right here. What this is saying here, kiddos, is this. It's saying the sine of x could be what value? Well, it could be 0, right? Guys agree with that? Or it also means that the part in parentheses, 2 cosine of x minus 1 could equal 0. Now, guys, this one's pretty nice for you, right? This is basically saying go down which column? Go down which column here? Sine column. Go down the sine column until you find what value? 0. So do that for me quickly. Go down your sine column. 0, 180, and 0 is the same as 360, so I could, do I have to include it? I don't have to, yeah. Yep, I'm sorry, yeah, should have just go. I get yapping and I forget.
I want to stay and listen.
I'm recording it, you can watch it on the bus. Well, why not? Learn Trig now, there's not a secant to lose. I think people think I'm weird. And you know what? That's okay. Because gosh darn it, I'm special. Oh, why you look at me like that? What did we say our angles were? 0 and 180?
Yes.
If you put 360, great. But I'm going to say x is 0 and 180 from this one. Now, bear with me on this. We're almost done. 0 and 180. Okay? This one here is a little trickier, guys. But if I can get the cosine, isn't this like 2v minus 1 equals 0? And isn't that like a linear part? Add 1 and divide by 2 to get cosine of x alone. You guys agree 2 cosine of x right here would equal 1 if I added 1 to both sides? Yes? No? Yes? Okay. I can divide everything by what value now? Get cosine of x alone. This now says cosine of x is what value? 1/2. Well, let's go down and find the value for this angle. Cosine of some angle will be positive 1/2 within that full revolution on your chart. What do you end up with? 60 and
270.
cosine, right?
Yep.
60 and 300, right?
Oh, sorry. I was
Oh, that's okay. 60 and 300 degrees. Okay. So how many answers were there in that set? 4 of them, right? 4 of them. See, I like the factoring part. If you can factor stuff before you divide, do it. Okay, nothing wrong with what's over here. Nothing wrong at all. And you can read through that. Did they get 60 here as an answer?
How come it only gave you a 0 and 60?
Because the way the notes were set up for this, they just did the inverse of the angle. And in the past, when this has been presented, Jackie, in the past, I don't think that the other classes had the chart. And I think the chart is a good thing to have to understand that 60 may not be your only answer. Okay? So you see where we're at with that? They're actually punching this into a calculator right here by doing it. We're actually using the chart to get our answers. And I think the chart is a nice verification for us to make sure that we know that we're doing things correctly, okay? Because when you check your answers in the back, when I give you the assignment today, Jackie, they're going to say 0 and 180. And if you're just punching it in a calculator, it's only going to kick out that lowest value for you. And you're going to be like, why in the world is this not showing up then? Makes sense why we have the chart now? Okay. All right. Guys, questions on any of this at all? Any at all? Guys, I'm telling you, you're doing some pretty tough stuff here. You should be pretty proud of the things you're doing. Again, I'll tell you people that have not taken the ACT yet, you will be so glad you at least went through this. Whether you understand it 100% or not, you're going to be way, way ahead of the game when the ACT rolls around. Okay? Promise you that. All right, so I'm going to stop this quickly.